Alright, let's make a
What
start.
chapter are we up to? Look, this was where it's like yesterday.
Try to be quiet.
The last bit of this chapter, so it's last chapter 3, whatever, 3J. Alright, so we're looking at transformations with the inverse matrix. So first of all, what is an inverse matrix? Inverse often means the opposite, so for an inverse matrix, if you multiply a matrix by its inverse, then you get the identity matrix, which is the matrix equivalent of the number 1. So when a matrix is multiplied by its inverse, then what you get is the identity matrix.
Oh, not this stuff.
Alright, the identity matrix, if you like to think about it as matrix equivalent.
That's just the kind of 1, 0.
Yep.
Or is that like the square thingy?
Alright, so the identity matrix we use I, so the 2 by 2 one is that. Because whatever you multiply, 2 by 2 matrix, whenever you multiply it by this, you just get that matrix. So in terms of multiplying a matrix by its inverse, so that there is the inverse. And one of the other properties of an inverse matrix is that it actually doesn't matter whether we put the inverse matrix in front or in the back, we still get the same thing. Alright. So inverse matrix is one of the few times when you multiply matrices, doesn't matter the order, usually it matters the order.
So they're the same thing.
So, what is the inverse of a matrix if we can actually find it? So if we have a matrix and we're only doing 2 by 2 matrices, so A, B, C and D, then a thing that's known as the determinant, and the determinant because it determines whether there's an inverse or not, is, and we write it as det A, and to find out what it is, you multiply the diagonals. So this one here, leading diagonal, A times D, and you subtract the other diagonal. So A times D minus B times C. And as I said, determinant determines if there's a matrix, an inverse. So the inverse, A negative 1, exists only if this doesn't equal 0. Alright, so if you work out the determinant and you find the answer 0, that particular matrix doesn't have an inverse. So what is the inverse matrix in terms of our matrix A? It is the following. 1 over the determinant, so AD minus BC, and then the matrix elements, these first two here, the leading diagonal as it's known, they swap. So whatever was down here comes up here and vice versa, so we now have D up there and A down here. And the other two become negative, like so. Right. Alright, let's do some examples. I'm going to leave that stuff there for the moment.
So basically, it's like, does it have an inverse matrix? And in that equation, B minus BC equals 0, that doesn't have. That's how you, that is, so that equation is how you find the.
Stupid head me go.
Like, he's trying to write example. I just want to.
Alright, so we've got a matrix A, it's 3, 2, 1 and 6. We're asked to find the determinant. So remember the determinant of A is A times D minus B times C, so it's diagonal minus this diagonal. So if we look at this particular one we've got up here, so it's 3 times 6 minus 2 times 1. Minus 2, which is 16. So that's A. B, I'll be able to squeeze in here. So the inverse matrix, when we look here, is 1 over, and that's the determinant, of course, which we found to be 16. So the inverse matrix is 1 over 16. Then it relates to our original. That we swap these two, swap them around so that 3 comes down here, 6 goes up, and the other two change their sign. Right, other two change their sign. Right, now that I've used that, alright, you could, if you wanted to, put that 1/16 in there, but it's just as neat as it is. And when I do the next one, you'll see that it's more convenient to actually have that 1/16 out there. Alright, so here's a matrix equation. So we've got A, which is this one, times some other matrix and this is the answer that you get. And the question asks us to find what this other matrix is. So first of all, so if we were doing normal numbers, we go, oh yeah, okay, well you divide by that, and there's your answer. And so remembering we don't have, in matrices, we don't have division, what we do instead of division is we multiply by the inverse. So if you like to think of it, multiplying by the inverse is the matrix equivalent of dividing. All right. Now if I'm going to multiply A by its inverse, I need to put the inverse next to it so that they're multiplied. So what I would then get is the inverse matrix times A times matrix X. Now what we do to one side we've got to do to the other, that doesn't change. And because I've put this inverse matrix here in front of this stuff, on the other side I've got to make it sure I put it in the same location. So I put it in front. Now, that bit there, inverse times the inverse, is just the identity matrix, and the identity matrix is the matrix equivalent to the number 1. So I don't actually need it. So to find matrix X, I multiply the inverse by that. So the inverse is 1/16. 6 minus 2 minus 1, 3, and then multiplied by 5, 6, 7 and 2. So leave the 1/16 out there, then we don't have any horrible numbers to worry about. And you can then get your calculator out. If you look in your calculator and you go to your keyboard and then you go to the tab that's Math 2, you will see a matrix template, or you'll see a few matrix templates. Now that's handy because we can do all of this in our calculator. In fact, I don't even need that 1/16 there because I can put that out the front of the matrix template. And because I've prepared one earlier, I know that when I do that, I get that as the answer. So matrix X is 1, 2, 1 and 0. Alright. Any questions about that? Anything need clarifying before we move to how we might use this for transformations?
Okay.
No. Right, I'll let you get that down, then I'll rub that off and we'll do an example where we use it for transformations. Right, we're done? Yes.
Yeah.
Alright, so a good question might say something like this. So given a transitive equation, alright, so the equation is matrix A times X plus matrix B is the new X. Right, so the image, you take the original, you add B to it, and then you multiply all of that by A. And so you would then be given some information about matrix A and matrix B. Matrix A, in this case, is 0, negative 4, 2, 0. And matrix B, in this case, it's a column matrix which is 1 and 3. And then you'll be asked to find the image of something. And so in this case, it's y equals 2x plus 5. Alright, now before I put matrices in there, I'm going to do a little bit of rearranging, because in this equation y equals 2x plus 5, we've got to find expressions for the original y and x. Now the original y and x are in this one, so it's handy to get this one by itself. And so normally when we would do algebra, we would, to move the A, we would divide by A, and remembering now though that A is a matrix, so to remove A, we need to multiply by its inverse. So then what that then leaves us with is matrix X plus B. And then to get matrix X by itself, we just need to take matrix B away. So we have the inverse times the image, take B. All right. So before we do all that, we need the inverse. So the inverse of A, we need the inverse of A. So the inverse of A is 1 over. Multiply those two things together, 0 times 0, which is 0. From that we're going to take negative 4 times 2, which is negative 8. So that would be next line down 1/8. And we swap these two, so 0 and 0, and we change the signs. So here's our inverse. All right. Yes.
Is it meant to be negative 1/8 or do you just not like that?
No, because you're taking away negative.
Oh, okay, yeah, that makes sense.
Negative here and negative there, taking away a negative, so it's a plus. All right, so let's now have a look at what this matrix equation is going to look like. I'll do that over here. So matrix X will be the inverse, which is 1/8, 0, 4, negative 2, 0, times the image. So the image is X dashed and Y dashed. And from that, we're going to take matrix B, which is 1, 3. All right, I'll apply a row, across the row down the column, 0, 4y dashed, minus 2x dashed, 0, that's it, minus 1 over 3. Now before, it's all right to do our multiplication with the 1/8 out the front, but before we do the subtraction, we've got to put it in. So that then would be 4y dashed over 8 and negative 2x dashed over 8, which of course can cancel down. So 4y dashed over 8, 4 goes into top and bottom, so y dashed over 2, take 1. Here we've got negative x dashed over 4, take 3. So what does all that mean? What all that means is, because of course this matrix, matrix X, is our original X and Y. So that means our original X and Y, X is now related to the image Y, the image over 2, take 1, and the original Y is negative X dashed over 4 minus 3. So now we've got those things, we can now replace the X up here by this stuff, and we can replace the Y up here by this stuff. Right, and I'll do that over here.
Oh, I've run out of space on this page.
Can I rub that out?
Yeah, I reckon.
Alright, so we've got y equals 2x plus 5, and so I'm replacing y by stuff with the image in it, and I'm replacing x with stuff with the image in it. And then you expand, collect like terms, rearrange, etc. Do you want me to do all that algebra?
No.
No. So we do all that algebra in there, and you get that the image is y equals negative x over 4 minus 6.
Is that the end?
And that would be the image of the line y equals 2x plus 5 transformed by that equation. Alright. So the procedure is pretty standard for each one. There's just a lot of algebraic stuff. So where you can, get your calculator to help you. Alright. So that's now the exercise 3J stuff on your work plan.